Hello, my name is Paul Johnson, a Solutions Architect with Amazon Web Services. Welcome to my talk today entitled Modernized on AWS for Agility, Resilience, and Business Value. Let's start by focusing on agility on AWS. Whatever the organization, our customers want to become more agile so they can innovate and respond to change faster. The applications that organizations need to build today are vastly different than in the past. They need to scale quickly and to potentially millions of users, have global availability, manage petabytes if not exabytes of data, and respond in milliseconds. These types of applications are what we call modern applications. When customers modernize, they enjoy the fullest benefits of the cloud, maximizing agility while minimizing operational load. Modern applications can be characterized along these 5 vectors. Their architectural patterns, modular services, operational model as serverless and automated as possible, developer agility, automated, abstracted, and standardized, management and governance via programmatic guardrails, and data management strategy, distributed and fit for purpose. Modernization, and specifically the adoption of serverless technologies, really changes how you work. And this applies to anyone who interacts with the application. With serverless, you're adopting a new application architecture triggered by events and rethinking how you store state information. You're also rethinking how you operate your applications. Let's study what these changes look like and how that impacts the builders and operators in your organization. Let's start by looking at what's different about a modern application architecturally. Historically, applications were built with monolithic 3-tiered web architectures that look something like this. So you see the typical 3 layers, web servers, application servers, and database servers in a stack. And here's how we see a modern application architecture. Yes, it does indeed still look a lot like a 3-tier web architecture, but with some very important differences. The first major difference with this architecture is that what we see here is not the entire application. This is not a monolith. Instead, we're looking at a single microservice. So let's zoom out to see the bigger picture. So our customers run tens, hundreds, or even thousands of microservices, which improves their scalability and fault tolerance. Usually microservices communicate via well-defined APIs, and many customers start the process of refactoring by wrapping their applications within an API. Zooming back in, the other key differences with this architecture that we want to explore today are these. First, compute. The logic you write is really what's important to differentiating your organization. Now we're building compute technologies that make focusing on this logic easier than ever. Application integration and communication. The way you communicate both within your application as well as between each service is different. We're talking about the different approaches to messaging, events, and APIs within your business. And then data. How and where you store your data is different in a modern application. In this application, we can see multiple data store options. Each database is serving a specific need. It's purpose-built for the task at hand. And data stores are also decoupled from the application logic. So let's dive a little bit deeper into these 3 areas on the next few slides. So when you use AWS, you have a variety of options for compute. If you look at the chart here, one option is you can start at the very bottom with our EC2 instances, virtual instances, and you can have access to all the different knobs you want to manage on an instance-by-instance basis. Or you could completely go serverless at the top layer with Lambda or Fargate, where you're focusing solely on the application logic and we handle all the infrastructure. So the layers of abstraction available to you with AWS empowers your developers. You have the choice to pick the layer of abstraction they're most comfortable with, and we'll provide you with the tools, services, and APIs necessary to help you build your application. Increasingly, we see customers opting to reduce their operational burden by choosing serverless services like AWS Lambda for their compute. Now let's talk about integration options. Broadly, we see two categories of integration: synchronous, or API-based integration, and asynchronous, or event-based. Modern applications use both types of integration. Now, there are trade-offs to consider based on your business requirements. Event-driven communication is nearly infinitely scalable, but also scales to zero, which can enable a cost benefit for you. APIs will have a lower latency typically, but we don't think that's always important as it seems. When customers say they need a certain latency, they're usually talking about an edge case, but when we actually look into their P50 and P99 response metrics, we see that the latency required is rarely as low as expected. So these are trade-offs to consider. And then finally, agility. Event-driven applications enable not just the decoupling of services, but also of the teams that built the application. And that's very important. So this facilitates a dramatic increase in team agility. Finally, we'll look at data, which underpins all of our applications. Our customers are considering what they're doing with their data and choosing the data store that best fits that purpose. For decades, the only database choice was a relational database, no matter the shape or the function of the data in the application. But the key point here is that not all application use cases closely match the relational model. Developers are now building highly distributed and decoupled applications, and AWS enables developers to build these cloud-native applications by using multiple database services for scale, performance, and manageability. Here's a summary of the categories of databases that we support at AWS. And you can see we have many different types. People want the right tool for the right job, and they want the right database for whatever their workload is. With AWS, you have this flexibility today. Okay, let's pivot now and discuss resilience, what it means and how you can achieve it on AWS. One of the tenets of good application design is to design for failure from the beginning. As Amazon CTO Werner Vogel says, everything fails all the time. Resilient applications provide continuous service despite disruption, natural disasters, human error, hardware failures, and the like. The key categories of application failure to think about are shown on this slide. Code and configuration. What happens when you have a failed deployment? Do you have the instrumentation to detect it? Can your CI/CD system automatically roll back? Infrastructure. What if a single instance or virtual machine is terminated? What if there's an impairment to a single data center? Data and state. This covers your data, your application state information, or even overload. What happens if your customers overwhelm your service? What happens if your database gets corrupted? Recently, we saw a good example of this with the FAA outage that grounded all flights in the United States. This was related to human error and databases together. Dependencies. What are all the things your workload depends on, including AWS services? What happens if a third-party dependency fails that you can't control? Do you gracefully degrade? Or what if their latency increases by 50% and slows down your application? And then highly unlikely scenarios. Very unlikely to occur, but some customers will need to consider them. So what if a natural disaster impacts power or infrastructure on the entire east coast of the United States? And we define resilience as the ability for workloads to respond and quickly recover from failures. The mental model for resilience is to think about three things. One, How can you build your systems to be highly available with resistance to common failure modes built in? 2, how can you recover your system if you run into rare but highly impactful failure scenarios? And then finally, this notion of continuous improvement. Resilience is not a one-time thing you can just check off your list. Continuous improvement entails things like implementing DevOps practices such as CI/CD to automate your delivery pipelines, introducing failures on an ongoing basis to test your system chain and test for teams for weaknesses, implementing ongoing observability and monitoring practices. As with security and sustainability, resilience is also a shared responsibility between AWS and the customer. AWS is responsible for resilience of the cloud, and our customers are responsible for resilience of their workloads running in the cloud. Now, this shared model can help relieve the customer's operational burden as AWS operates and manages and controls the components from the host operating system and virtualization layer down to the resilience of the infrastructure. You see these things in the orange part of the slide. We take those off your plate. More specifically, AWS is responsible for ensuring resilience of the infrastructure that runs all the services offered in the AWS cloud, including hardware, software, networking, and facilities. The customer's burden for resilience will vary based on their selection of the individual AWS services being used in the solution, such as the selection of compute services and databases we discussed in the previous section. Some of those will require more customer attention than others. Now here's an example of how AWS implements resiliency of the cloud. AWS has 30 regions located all over the world and 5 more AWS regions coming soon. Within these regions, we have 96 availability zones, or we call them AZs. AWS regions are actually geographically organized clusters of data centers. And each AWS region is composed of multiple availability zones, or AZs. And then each AZ in turn is one or more physical data centers. So the AZs are independent of each other, each with their own power and water supplies. They're separated by a meaningful distance, meaning no shared fate from environmental disruptions that may occur, but still close enough together to be used together as a single logical data center with low latency. So here's an example of architecting a solution to take advantage of the multiple availability zones within a single AWS region. In the event of availability zone impairment, this architecture requires no action, as the EC2 instances in the impaired availability zone will start failing health checks, and the application load balancer will shift traffic away from them. Now, to build the stack in the first place, we leverage AWS CloudFormation shown at the bottom to automate the deployment, which removes the possibility of human error. And then we also provide a lot of monitoring and management tools to give you the observability that you need, shown at the bottom. So with this simple design, we mitigate many of the common causes for interruptions, as you can see on the left. However, not all causes can be mitigated. If an operator error does occur, this does have the potential to corrupt the system. So this requires a recovery plan so you can figure out how you're going to go back to an acceptable application state. So let's look at some options for this on the next slide. Disaster recovery strategies available on AWS can be broadly categorized into the 4 approaches we see here on the slide, ranging from low cost and low complexity of just making backups, which you can see on the left, to more complex strategies using multiple regions and active-active architectures, as you see towards the right. Now, these will come with a much higher cost, but much lower recovery point objective, RPO, and recovery time objective, RTO. So your disaster recovery strategy should be determined based on your business continuity need. So think about that very carefully. And then finally, it's very critical to regularly test your disaster recovery strategy so you have confidence when you have to invoke it, should it ever become necessary. Now that we understand agility and resilience a little better, how do these virtues translate to business value achieved on AWS? The answer may surprise you. Let's dive in. So here's some customer quotes from public AWS case studies. So they have the first person on the left. They're actually talking about the infrastructure cost savings that they get from running on AWS. The second person is talking about their ability of their applications to scale to meet the workload for peak times and scale back in seamlessly. The third person is talking about being able to focus on their business logic instead of heavy, undifferentiated lifting for infrastructure items. And finally, the fourth person is very excited about the sustainability offered by AWS, since our data centers run very cleanly as compared to most corporate data centers. Here is a high-level view of the cloud value framework across multiple dimensions. Cost savings is realized by avoiding provisioning on-premises infrastructure with large fixed spend, and then reducing the ongoing variable spend through the AWS economies of scale that we offer. Staff productivity means increased output by the same size team by removing the undifferentiated heavy lifting of mundane tasks such as system backups. Operational resilience is achieved by enhanced availability, security, and less downtime. Business agility is increased by the new products, the new geographic location expansions, or more features of the existing products and services that your team can now deliver more quickly, which can lead to new revenue streams. Sustainability means reducing the environmental impact of your IT operations. So on our final slide, we will show how business value from AWS is perceived by our customers. And this is where the big surprise comes in. From this 2022 IDC research study, most of the business value of AWS Cloud comes from other areas besides direct cost savings on computing infrastructure. This study showed that 95% of the value actually comes from productivity gains and increased business agility. So many of our customers initially enter AWS focused on infrastructure cost saving potential, but over time, they observe these much more impactful benefits to their business. So I'd like to thank you for your time today, and please let us know how we can help you modernize your applications to unlock more business value by running on AWS. Thank you.